There are a variety of extinguishing agents in use today. Some of these are developed for use on a specific class of fire, while others are effective on multiple classes. Click on each agent for details. Water has a cooling or quenching effect that reduces the temperature below the autoignition point, thereby eliminating the heat side of the fire tetrahedron. Water is used exclusively on Class A fires. It must never be used on Class B, C, or D fires. Water will spread a burning liquid fire over a larger area, making the initial fire more difficult to fight. Water used on a burning metal can result in a dangerous explosion. If used on an electrical fire, the stream of water may act as an electrical conductor, causing the electricity to follow the stream directly to your hands, resulting in electrical shock or death. Carbon dioxide, or CO2, is a gas that extinguishes a fire by smothering it, thereby removing the oxygen side of the fire tetrahedron. CO2 is effective in combating Class B and C fires because it has a high rate of discharge, it leaves no residue, is non-corrosive, and will not conduct electricity. Because it is a gas, it is easily dispersed in windy conditions and must be used at close range. Although CO2 is not poisonous, it should be considered toxic in an enclosed area. Most dry chemical extinguishers consist of a mixture of specially treated sodium bicarbonate that coats the surface of the burning material and interferes with the chemical chain reaction in the flame, thus depriving the fire of oxygen. Although dry chemical is typically used on Class B and C fires, multi-purpose or ABC extinguishers are also available and can be used to extinguish Class A fires. The chemical used in dry chemical extinguishers can be difficult to clean and can be corrosive to certain materials used in aircraft construction. Foam is used to blanket flammable or combustible liquid fires and both cools and eliminates the heat and oxygen sides of the fire tetrahedron. It is based upon a blend of bicarbonate of soda and aluminum sulfate and is most effective on pooled flammable liquids or Class B fires, where the foam can settle on the surface and minimize vapor formation. It can also be used on Class A fires. It is not effective on vertical surfaces or where the burning liquid is being ejected under pressure, such as a broken fuel line. Dry chemical may be more effective on these types of fires. Halogenated agents, commonly referred to as halon, extinguish fires by breaking the chemical chain reaction of the combustion process by preventing the bonding of oxygen and fuel molecules. Production of halon ceased due to the Clean Air Act, but there are halon extinguishers used to fight fires inside aircraft cabins. These extinguishers are electrically non-conductive and do not leave residue after use. Halon is most effective in extinguishing Class B and C fires within the aircraft cabin. Class D fires involve combustible metals. Specialized agents such as metal X, G1 powder, and sodium chloride are effective in fighting the unusual characteristics presented by burning metals such as magnesium or titanium. Class D extinguishers contain a specially blended sodium chloride-based dry powder extinguishing agent. Heat from the fire causes the agent to cake and form a crust, excluding air and dissipating heat from the burning metal. The most common type of Class D fire you may run into at an airport would be landing gear, made up of varying metal components that could have ignited during landing or taxi. Each of the extinguishing agents shown is available in portable handheld containers. Portable fire extinguishers vary in size dependent upon the type of fire risk likely to be encountered. All containers are clearly marked for the class or classes of fires they are approved to extinguish. Your airport or FBO will provide the type, size, number, and appropriate location of extinguishers needed to promote fire safety.